All right, welcome back. We're here in section 11.2. We'll split this up into three sections. We're going to be talking about tests about a difference in means. So things that we've done in the previous two chapters as well. So some familiarities on how we apply that. So again, looking at our learning targets, we have those here. We'll check those off as we go along and make sure that we're able to do those things. All right, so what we're looking for is the significance test for the null hypothesis. Basically, it's the difference between means equals our hypothesized values. Typically, we're going to set that equal to 0, suggesting there's no difference, which really means that the two means are equal. That's two different ways of saying that, really. So again, our conditions, make sure that we're doing those. Remember that normal large sample. Remember, if it's bigger, if the sample size is bigger than 30, that's good. If not, make sure that we're graphing, showing that there's no skewness or outliers if it's below 30. Okay, so here we go. Let's take a look at it. So let's find this. Has the mean number of hours American has worked in a week changed? One of the questions on a general social survey asks respondents how many hours of work they work each week. Responses from random samples of employed Americans were recorded for 1975 and then 2014. They're summarized there. We have some data there. Do these data give convincing evidence at the 5% significance level of a difference in the true mean number of work hours per week for Americans in 1975 and 2004? So we're going to state the appropriate hypotheses, define those parameters, and then we're going to check to see if our conditions are met. Okay, so here we go. The hypothesis would be that that the mu of 2014 minus mu of 1975, the difference of those is 0. That's we're going to say there is no difference as our null hypothesis, and our alternative, of course, is that, well, we think there is a difference. We didn't really say it was less than or greater than. We're just saying we think there's a difference, so we have our two-tailed test in that case. So mu sub 1 is the mean hours worked by Americans in 1975. U sub 2 is the mean number of hours worked per week in 2014. All right, so let's check our conditions. We had independent random samples, yes, 10%. We believe that that is certainly less than 10% of all working Americans in the respective years. And let's see, our sample sizes of 764 and 1501 are all over 30, so we're good. We don't have to graph and check skewness or outliers or anything like that since we're over 30. Okay, so again, we're going to look at our test. Now again, because we're finding the difference, okay, put the difference between the means here, minus 0, we're saying it's 0. And then make sure we're doing our standard deviation here. Now, I would use the calculator, is what I would use, and we'll talk about that in just a second here, but that's the formula that's being used. And again, I really think option 1, the technology using the calculator, is a better deal in this case. So here we go. So why does it give some evidence? Well, you can see some evidence. Again, the mean in 2014 was 41.91, and in 1975 was 38.897. That's a difference of 2.94. So that certainly gives some evidence. Now, is it convincing? Well, that's another story, isn't it? Let's check and see if it is. So we're going to calculate this. Now, again, if you were using the formula, this is what you'd put in there. Okay, so you'd put the difference of the two means, which is 2.94. Take the standard deviation squared over the sample size plus standard deviation over sample size, add them, square root. You can see a lot of places to make errors. I would use the technology again. You can go to your calculator, watch the Tech Corner video again from our online presence. We have those loaded up for you. But again, you'd hit Stat, Test, and then go to number 4, which is a 2-sample t-test, is what you're going to look for there, and you'll be able to get that exact answer right there. Now, again, if you use that, we're going to get a definite p-value of, now again, it's going to read it off as 1.15 times 10 to the negative 6. So make sure you move those decimals over. So 0.00000115. Now, if you use the table, and this is why I don't necessarily like that, is that you're going to have to do that, multiply it by 2, and you can kind of see, yeah, those are different. I mean, yeah, the technology, I think, is a way better, more accurate way of doing it. So I would encourage that as opposed to using the table. Okay, so conclusion, because our p-value is way smaller than our alpha here of 0.05, our significance test, we're going to reject the null hypothesis, and we're going to say that there is indeed concluding evidence or convincing evidence of a difference in true mean hours worked from Americans in 1975 and 2014. We're going to say that. All right, so that's just kind of tipping it off. We have a couple problems for you to check out on page 735. I would certainly do those 35, 37, 39. Those are certainly well worth your time. And then we'll pick up and kind of put it all together tomorrow on the next section as we go. So until next time, I'm Mr. Boone.